Hey everyone, welcome to The Explainer. So today we're unpacking a truly mind-bending scientific breakthrough, and this is based on some fantastic reporting from Live Science. Now I want you to just picture something for a second, okay? Imagine a glowing, ethereal blue cloud of atoms, just floating there, completely suspended in the total, absolute darkness of space. It's a wild image, right? Well, that incredible visual is exactly what we're exploring today as we break down what scientists are calling the fifth state of matter.
Okay, let's dive into this. Why is NASA freezing atoms almost to absolute zero aboard the International Space Station? I mean, it sounds totally like science fiction, doesn't it? But no, it is happening right now, literally hundreds of miles right above our heads. See, we've got these massive, universe-bending scientific mysteries that we desperately want to solve down here on Earth. But, to actually crack the code, we had to leave the planet entirely.
So to understand why they're doing this, we really have to talk about the deep freeze in space. You see, the International Space Station, it isn't just a place for astronauts to live and gaze out at the Earth. It has literally been transformed into a high-tech cosmic freezer. And look, when I say freezing, I definitely don't mean a cold winter's day. I mean chilling atoms down to mere fractions of a degree above absolute zero. We're talking about the absolute coldest temperature theoretically possible in the entire universe. But it begs the question, why go all the way to space just to make things incredibly, unimaginably cold?
Well, now what's really interesting about this is the answer lies in something called a Bose-Einstein Condensate. Okay, I know, that sounds like incredibly heavy scientific jargon, but please don't let the name intimidate you. For everyday folks like you and me, honestly, you can just think of it simply as the highly unique fifth state of matter. I mean, we all grew up learning about solids, liquids, gases, and plasma, right? Well, this right here is number 5. When you actually manage to get atoms to this extreme freezing temperature, they completely stop behaving like individual, bouncing particles. Instead, they actually sync up. They start acting together like one single giant superatom. It's just a bizarre, truly beautiful state of matter that is totally different from anything we interact with in our daily lives.
But here is the massive hurdle scientists faced when trying to study this stuff. It basically comes down to a battle of environments: Earth's gravity versus space's microgravity. See, if you try creating this incredibly delicate fifth state of matter here on Earth, gravity just immediately ruins the party. The strong pull of Earth's gravity drags those delicate atoms down, and it makes the supercooled cloud collapse almost instantly. It literally gives scientists just fractions of a single second to observe them before the whole experiment just totally falls apart. Honestly, it's kind of like trying to study a snowflake inside an oven. So to truly understand these fragile atoms, scientists realized, hey, we have to completely remove the heavy hand of gravity from the equation entirely.
So the crucial point is that the microgravity environment of the ISS is the secret ingredient making this whole experiment possible. Up there on the space station, without that constant aggressive downward pull of Earth's gravity, this delicate glowing atom cloud can just float freely in the chamber. That microgravity allows scientists to hold on to this bizarre fifth state of matter for seconds at a time, rather than just milliseconds. And let me tell you, in the fast-paced quantum world, that extra time is an absolute eternity. It completely unlocks their ability to finally actually observe how these supercooled atoms behave.
Let's move to and see how this builds into something that will deeply impact our everyday future. Because the progression is actually quite simple, right? First, you take those atoms up to the ISS, and you freeze them to near absolute zero. Second, that extreme, mind-bending cold creates our Bose-Einstein Condensate, that bizarre fifth state where the atoms just kind of blur into one. And finally, step 3, by studying this stable cloud up in space, we pave the way for future quantum technology. Like, this isn't just a neat little parlor trick in orbit, guys. It is a vital stepping stone to completely reshaping our world.
And this brilliantly illustrates why this complex science actually matters to every single one of us. You see, understanding this fifth state of matter, it isn't just some abstract experiment locked away in an orbiting lab somewhere. No, it is the very foundation of our quantum future. Because these supercooled atoms move so slowly and so uniformly, scientists can measure them with unprecedented precision. By learning how to control atoms at this fundamental, basic level, we are laying the groundwork for ultra-powerful quantum computers. We're talking about machines that could solve problems in literally seconds that would take today's computers thousands of years to figure out. We're looking at completely unhackable communication networks and incredibly precise sensors that could just totally revolutionize global navigation. The everyday tools of our tomorrow are literally being built from those freezing atoms today.
Which really just leaves us looking up at the stars with a massive, exciting question. What other quantum secrets will humanity unlock now that we've harnessed the fifth state of matter in space? NASA has essentially just kicked open a brand new door in physics by using the space station as their ultimate freezer. The revolutionary technology of our future is literally being chilled into existence right now. So definitely keep your eyes on the skies, because when it comes to quantum technology, trust me, this is just the beginning. Thank you so much for joining me for this explainer, and as always, stay curious.